Hi guys, today's GFG problem is find duplicate rows in a binary matrix. Okay, binary matrix is a matrix with zero and ones, right? Okay, given a Boolean matrix of size R and C, R represents rows and C represents columns here, number of rows and number of columns, where each cell, like I comma j cell, contains either zero or one. As I said, binary matrix contains only zero and one, right? Find the row numbers zero based of row which already exist on or are repeated. Okay, we have to find the rows. We have to, like in a shortcut way, we have to find the duplicate rows. Okay, like duplicate rows in a sense, like for example, how are duplicate numbers represented in array, like 1 comma 1, 2 comma 3, 2, 4, 3, 3, 4. Like 1, 2, and 3 are duplicate, right? Like they are repeated twice, right? So they are already, they are repeated, so they are called duplicate numbers. Like, okay, in matrix also we have to find the indexes of the duplicate rows. Okay, for example, 1 comma 0 is row, like 1 comma 0, the elements of row 0 is 1 comma 0, and the elements of row 1 are 1 comma 0. So the elements of row 0 and the elements of row 1 are equal and uh, have the same place at the indexes on each row and on either row, like on every column, they are similar, they are equal numbers in the column, so these are said to be like duplicate rows. Like one of the duplicate row is like first row 0 has come, right? So then duplicate row will be row 1, so row 1 is a duplicate row here. Okay, now coming to this example, like 1 comma 0, 0 comma 0 for 0th row, and one, if you carefully observe, 1th row also is same as 0th row, so we can say that 1th row is a duplicate row. Now this is not a duplicate row, it is not matching with any of the rows, right? So this is not a duplicate row, and this is a duplicate row because this is matching with this second row, right? So third index is printed as an answer. So we have to print, what we have to return, we have to return array of integers, right? List of integers, like the integers are indexes of the duplicate rows. Okay, so how to approach this problem? Okay, now, like, how can we know that they are duplicate there are duplicate numbers in an array? For example, if we take an array, single dimensional array, how we will identify whether there is a duplicate number or not? By using a set, right? So we keep on we will be iterating on over the array, and we keep on adding elements to the set, and we will be checking one condition there. If set dot contains, if it already contains the value, then it is a duplicate number, right? So if we are at an index where it already present in in the set, then it is called a duplicate number, right? Same in the matrix also. We have to find the duplicate rows here. So here you can say that we can't compare a list, right? Like a list comparison is complex here. So what we will do is we will be storing every element of row of a particular row in a string, and we will be comparing string rows every time. Like that will be easy, right? So for example, row 0 string will be 1 0. This is the row 0 string, and row 1 string will be 1 0. Now these two are comparable, right? Like we can compare these two strings, right? So if we compare these two rings, they are equal in size and they are equal in nature also, right? Like they are equal to each other. Like string node equals zero row zero dot equals row one is equal to true here because they are equal in nature, right? So in this way we can compare, right? Like what we will do is we will take a data structure called stat and data structure called list to store the indices of the duplicate rows, and we will be iterating over matrix here, and for every row we will be storing all its elements in a string, and we will be comparing it with the remaining strings in the set. If it is present, then it is a duplicate row. If it is a duplicate row, then we will be adding its index to the array list. If it is not, then we will be adding it to the set. That's it. Simple. Okay. Yeah, the pseudocode will be set of string, okay, and list of integer, okay, and we will be iterating over 0 to m for 0 to n. As I said, we will be storing all the index, all the elements in a string. So string answer equal to this thing, and answer plus equal to, if it is a mat, let us observe, we will be storing, and we will be comparing it. If set dot contains answer, if it contains answer, then it is a duplicate, right? So we will just add list dot add I to the list currently, or else we will be adding answer here, like simple, right? So this is the pseudocode, and at last we will be returning list here. That's it. So this is the implementation here. This is the pseudocode of the solution, and coming to the code of the solution, it will be same. I have taken array list here, and I have taken string here, asset here, and I have iterated over matrix here, and have taken answer variable to store the to add the all elements of a particular row, and I have added all the elements of the particular row, and I have compared it with the set of elements here. If the answer string is already present in string, then we can say that it is a duplicate values, and then we can store it in a then we can store the index in a list, or else we can store it in a set, right? So this is this is the solution of this problem. And coming to the time complexity of the problem is, and we are using two for loops here. One is for m and one is for n, and this averagely takes big of 1 or big log n. For this this time complexity is varying over the version of Java also here. If you are using Java 7 here, it will be log n, and if you are using Java 8 here, and it will be big of n, and at average cases it will be big of 1 only. So we can say that it is a big of n up. It takes big of n time complexity to compare it with the other strings, okay? So if we observe, the overall time complexity will be big of m into n only, okay? And space is big of n. Like if there are no duplicates in the matrix, then we will be taking m rows, right? We will be storing m rows in the asset, right? So the time space complexity will be big of m only. So this is the solution here, and thank you.